Hi, I'm happy here to present our work on detecting JavaScript injection via website behavior fingerprint. This joint work by Chih-Chun Liu and Hsiao from National Taiwan University and Tiffany Kim from HRL Laboratories. Normally, when Alice browses a web page, this page may also contain or load a piece of JavaScript code. This script runs in the context of this page, which means that it can do whatever the page can do. However, if the connection is not protected by HTTPS, a man-in-the-middle attacker will be able to replace it with a malicious script. For example, this malicious script may secretly request some advertisements, which were not included in the page originally, and Alice is exposed to these unwanted advertisements. It has been observed that some ISPs and proxies are doing this to increase revenue. This malicious script can also exploit this innocent user, Alice, to participate in a distributed denial of service campaign, flooding a victim server with a lot of requests, without Alice noticing it. While the previous attack may be prevented by limiting cross-domain read, limiting cross-domain read here cannot prevent this browser-based DDoS attack because the attacker has been effectively depleting the server's resource, regardless of whether the script can see the response or not. Previous work to mitigate JavaScript injection can be roughly divided into two types. One that limits illegal JavaScripts or subsequent requests based on server-defined policy. However, policies are often hard to correctly configure and require the server support. The other type aims to verify the integrity of web content. However, some of them are not robust to an active man-in-the-middle attack, and some also require the server support. In this work, we present the design of a lightweight system to detect JavaScript injection via website behavior fingerprint. Our key intuition is that JavaScript injection often changes the website's observable behavior, such as sending additional requests to previously unseen domains. Hence, we design a system that enables a client to locally compute website's fingerprint and compare it with previous known ones to detect potential behavior changes. The main advantage of this approach includes that no server support is required, and we avoid the need to configure blacklist or whitelist policies. So far, we have investigated 3 fingerprint constructions and evaluated their accuracy and performance. All of them consider the set of external requests sent when loading a website. Some consider the frequency of requests and use different ways to represent the frequency, and some do not consider frequency. These data are stored in a compressed fashion in sketch-based data structures such as Bloom filters and content Bloom filters for efficiency. We observed that reasonable accuracy can be achieved, and more interestingly, different construction methods are suitable for different types of websites. We have so far investigated Bloom filter and content Bloom filter fingerprint methods. As for the future work, we would like to explore different fingerprint construction methods while analyzing the trade-offs between privacy and fingerprint availability. We also would like to further evaluate the robustness of the fingerprints to dynamic factors, including location, browsing time, network environment, and browser version. Finally, we would like to enhance our system by allowing it to select different fingerprint methods based on website's characteristics. Thank you.